In this lesson, we're going to talk about point-slope form of a linear equation. This is the second form of a linear equation that we're going to talk about this year. The first one being slope-intercept form. Basically what this is it's another form of a line that you can graph on a coordinate plane. And you can see that we have the formula here to the right, and this is what the equation of any line in point-slope form looks like. The formula is y minus y1 equals m times x minus x1, where m remains as the slope, and x1 and y1 represent a coordinate that is going to be located on that line, which is on the coordinate plane. So let's go ahead and start really easy here by just taking some information and putting it into the formula. So to create an equation in point-slope form, you need a point and a slope. So you can see that we're given the slope of -4 and a point of 4, 6. So let's go ahead and plug it into the formula. My slope is going to be represented by my variable m, and then my coordinate here is going to be x1, y1. So if I label everything just like this, it's really easy to pop right into the formula. So let's go ahead and write y minus y1 equals m times x minus x1. And we're done. This right here represents a line on the coordinate plane that has a slope of -4 and that is going to run through the point 3, 6. All right, let's go ahead and try another one. This time we're given a slope of 5, so that's going to represent my variable m. And this time I'm not given a point necessarily, but I'm given the information that the y-intercept is -3. Now, using that information, I can detect that the y-intercept of -3 is actually indeed going to give me a coordinate, isn't it? It's going to give me the coordinate 0, -3, which is going to represent my x1, y1. So you had to dig a little bit deeper for that one to kind of think about the point that they gave us. So let's go ahead and put it into the formula now. Y. Now, I'm going to stop here for a second because there's something that's kind of interesting here. Do you notice how my y sub 1 is a negative number? Well, if you look up at the formula, you can see that y minus y1, there's a subtraction symbol there. Well, really what it's saying is y minus -3, right? Because isn't y sub 1 -3? When you subtract a negative, it's actually going to change it to a positive. So it's going to be y plus 3. And that's just using integer operations. Let's continue. Equals my slope, which is 5, times x minus my x1, which is 0. And I'm finished. So the trickiest part of that problem was identifying that negative in the formula. It also works the same way with the negative on the other side of the formula with the x's, and we'll see that a little bit later on. Okay, now what we're going to do is we're going to determine the point and the slope used to construct the equation. So really what we're doing is taking the equation in point-slope form and we're deconstructing it into its pieces. So here's the line. And we want to first come up with the slope. The slope is going to be the easiest thing to identify. Our slope in this case is going to be -2. Now the point that we're going to represent our x1, y1, we have to pull out. So let's go ahead and look at the x's first. Notice how the x has a negative right in front of that 3. That corresponds with the original formula. Therefore, the 3 is going to remain exactly the way it is as 3. There's no double negative there. Looking at the y, you can see that I also have a minus sign there. So therefore, I'm going to take that 8 and I'm going to place that right next to my y sub 1. Okay, so now that was just kind of plucking out the x1, y1 right out of the formula. But let's look at the next one because this one's going to change a little bit. First, let's identify our slope. Our slope looks a little different now, doesn't it? We just have a negative. Well, we learned back in Unit 1 that anytime you have a negative by itself, it really has a 1 standing next to it. So our slope is going to be -1 in this case. Now, our coordinate, our x1, y1, let's see what this is going to look like. Let's focus first on our x. Notice how it's a minus sign, which corresponds to really what our formula looks like. So we're just going to take that number and we're going to place it right in the x coordinate. Now let's look at the y. Notice how the y has a plus sign. In order to get a plus, we really needed a negative negative to be next to each other, which means that that 6 right next to it was originally negative 6, giving us our slope and our point. So you can always go forward and backwards with these types of problems. Okay, now just kind of reviewing the basics here of point-slope form. The idea of this type of linear equation and why we have this form is basically saying that if you have a point on a line and you have a slope, then you have an equation. So this is the specific equation that we use when given that specific information. So let's go ahead and look at how to graph an equation in point-slope form. You might be thinking, well, just like slope-intercept form, if I had a point and I had a slope, I could graph it, right? The point being the y-intercept and the slope being the slope. Well, it works the same way here. We need a slope and a point. So let's go ahead and identify the slope first. Our slope in this problem is going to be negative 1/2. And our coordinate, which is going to be our x1, y1, we're going to go ahead and pull out and deconstruct the equation. So if we go up to the equation, we can see that the x has a plus sign next to it, which means that that 2 had to be negative. It had to be one of those double negatives. So I'm going to go ahead and put negative 2 in my x position. Then if I look at my y, I can see that I have a negative, which means that this is indeed a positive number just as it is right now. So there we have our coordinate. All right, when you have a slope and you have a point, the way that you graph it is you always take the point and plot that first. So I'm going to go ahead and plot that on my coordinate plane. I'm going to draw a nice dot. And then I'm going to go ahead and take my slope. I'm going to draw in my slope. You can see that my slope here, my slope is negative 1/2, which means that my rise is negative 1 and my run is 2. So I'm going to go ahead and do my slope here. Negative 1, positive 2. And I'm going to continue that slope all the way down my page. I can even add one up here at the top as well. I like to extend my coordinates all the way across my graph to make it nice and neat. Once you do that, you can go ahead and draw a nice, neat line using your straight edge right through your coordinates. And you can include those 2 arrows at the opposite ends, indicating that this line will go on forever. And you've graphed your equation in point-slope form. Okay, as you look at that graph, you're probably thinking, well, I can also write this equation in slope-intercept form, and you're exactly right. And that's where we're going to be headed here shortly. Okay, let's look at another one. Determine the linear equation given the graph. So we could take this linear equation, we could write it in slope-intercept form. We know how to do that. But this time we want to write it in point-slope form, because this is the second type of equation that we are talking about. So let's go ahead and do that. The first thing we need is a point, and the second thing we need is a slope. So let's go ahead and figure out our point. You notice that I have 2 points on this line. And if you're really clever here, you actually see that I actually have those 3 that are right there on my graph that I can actually see with my eyes. But we also know that there are going to be hundreds and hundreds and hundreds of points on this line. I like to stick with the ones that I can see. So I'm just going to go ahead and I'm going to select this point that I'm circling. That's going to be the point 1, -3. Then I'm going to find my slope. And my slope is going to be a rise of 3 and a run of 2. So 3/2. Now that I have that information, I can go ahead and plug it right into my point-slope form. So y. Looking at my y here, I have a negative, so that's going to make it a positive 3 equals 3/2 times x minus 1. And there's my equation of that line in point-slope form. Now you might be wondering, well, what if I didn't choose that point right there? And what if I chose the point right up here? Well, that's perfectly fine. Your equation is just going to look slightly different, and here's how. The point that you have here is going to be 3, 0, but your slope is going to remain the same. When that happens, it's just going to change your equation. So let's go ahead and change it. Y minus 0 equals 3/2 times x minus 3. And therefore, you have this equation. So what's unique about point slope form is that you can have equations that look a little bit different, unlike slope intercept form where you only have one way to write it. So just be aware that all you really need is to select one of these, and one of them will suffice. All right, let's talk about those special graphs that we talked about back when we talked about slope intercept form. Do you remember these, the ones that are vertical and horizontal? If you remember what we talked about in that lesson, we talked that every single vertical line is going to look exactly the same. Likewise, horizontal lines, the equation is going to look exactly the same. If you remember correctly, vertical lines are going to be x equals, and then wherever it crosses the x-axis, that's going to be what it equals. So this equation is going to be x equals 1. And then my horizontal line is always going to be y equals, and wherever it crosses the y-axis is going to be what it equals. Now, I know these don't look anything like an equation in point slope form, but these are special graphs, meaning anytime you have those types of lines, you're always going to have the same type of equation. Okay, let's go ahead and do some interesting things with point slope form. All right, let's look at this first example. Let's say that it says determine the linear equation given 2 points on the line. The only information that I am given is these 2 points, and these 2 points happen to run on the line that I am trying to figure out what it is. So in order to do this, we have to kind of think. We have to think back to when we talked about slope. Do you remember that whenever you have 2 points, you can identify a slope? Well, that's what we're going to do here. So anytime you have 2 points, go ahead and find a slope. So I'm going to do that by substituting it into this formula. Do you remember this? y2 minus y1 over x2 minus x1. That's going to be our slope. So I'm going to start by labeling my points, just like we did before, to make sure we're nice and neat and organized. x1, y1, and then x2, y2. And just as a reminder, you can flip those coordinates around. The first coordinate can be x2, y2, and the second coordinate can be x1, y1. It doesn't really matter the order. Now I'm going to go ahead and plug it in. So my slope is equal to 3 minus 1 divided by 3 minus 2. I'm going to go ahead and simplify that down to 2 over 1, which of course simplifies down to 2. So therefore, my slope is going to be 2. All right, now that I have a slope, I want to put it into point slope, so I need a point. Luckily, I have 2 points to choose from, don't I? I have A and I have B. Now, either one is perfectly fine to choose, and I'm going to go ahead and start with the first one. I'm just going to go ahead and write my equation. So I'm going to say y minus my y1 equals my slope times my x minus my x1. This is one way you could write this linear equation that goes through these 2 points. Now, let's say that you wanted to use B. So we'll call this A, and we'll do the next one B. That would be written as y minus 3 equals 2 times x minus 3. And you're done. So either one of these is fine. You don't need to write both of them. One of them will suffice. Okay, the next one. Oh, I love this problem. Determine the linear equation given the following information. The slope is an undefined slope, and it passes through the point -1, 5. So we want to write this in point slope form. We want to write the equation. So we need to know a couple things here. First of all, we need to know what an undefined slope is going to look like. We know that undefined slopes look like vertical lines, don't we? We learned that in the very first section of this unit. Now, I'm just going to go ahead and draw a little sketch because you might be able to really identify what's happening here. But I want an undefined slope that passes through this point. So let's say that this point is here at -1, 5. And I want an undefined slope, or a line with an undefined slope, to go through that point. Therefore, it's going to look something like this. We're looking for the equation of that line, which, well, we know it's vertical, so therefore it's going to be x equals, and then it crosses the x-axis at 1, So the equation of this line in point slope form is going to be x equals 1. Remember, this is a type of special graph. Okay, now we're going to get into some really fun stuff. This is going to be kind of the meat of this unit and some of the next unit, where we're going to be talking about transferring from one form of an equation to another form. So I'm going to start by showing you how to do this, and then we're going to be building on this as we go along and learn the other form. So let's start and take this equation that is a linear equation, and it's in point-slope form, and we want to transfer it into slope-intercept form. Because we could take this line right now and graph it on a coordinate plane, or we could take the slope-intercept form of it and graph it on the coordinate plane, and it would be exactly identical. So let's just see what it looks like to put it in slope-intercept form. So I'm going to use my equation skills, and I'm going to solve for an equation that's in the form y equals mx plus b. So let's go ahead and do this. I'm going to start by distributing my -3 into my x and into my 1. That's going to leave me with y minus 1 equals -3x minus 3. I'm going to finish it off by adding 1 to both sides. And when I do that, I'm going to get y equals -3x minus 2. This right here is the slope-intercept form of the equation that we began with. So these two lines that I pointed to here, they both will create the exact same line on the coordinate plane, which is kind of cool. Now, what if I start with slope-intercept form and I want to put it into point-slope form? Well, there's one additional little piece of information that you have to recognize here. So if we want to put this into point-slope form and we're looking at it, we can already identify the slope, right? We can see that the slope is going to be 2/3. Now, where do I get the point from? The point is going to be located by the y-intercept, because isn't a y-intercept a point on the coordinate plane? The point is going to be at 0, -3. Once I extract that information out of my slope-intercept form, I can easily put it into point-slope form. Y plus 3 equals 2/3 times x minus 0. And I'm all done. Okay, the key thing to know about point-slope form is that you can always create an equation given a point and a slope.